Last class, we did discuss about constant classes, constant class properties, type def classes, and then uh, protected access qualifiers. So you know that protected access qualifiers means the family members only access that properties. Whatever the constant protected properties you are considering, those will be operated in your parent class as well as child class. And the outside persons like TVs don't have any access to call that protected properties. Okay. And then constant class properties. We are using properties in our class that is constant. Global constant and instance constant. Global constants means while declaring only, we are assigning some value. Okay. Throughout simulation, the value can be changed. That is global constants. And then instance constant means at your instance you are assigning some value. Okay. So normally we are assigning like transaction.address, transaction.data equal to some values we are assigning. In the same way, while the simulation time we are assigning the values, through constructor only we are assigning the values. Okay, remember. So for constant properties, we can't access in the TV directly. So whatever the how we are assigning the values through constructor. Constructor function new is there and then property constant is there. That constant we can call in a function argument or as well as directly we can replace that value. We can assign the value. Okay. And then type def classes. If you want to declare A, we need to know B. Or you want to declare B, we need to know A. Okay. So because in system verilog, topmost hierarchy is following. So you are representing class A, and inside that B handle is representing. But the class A don't know which is the class B. Okay. Then the compilation error will come. To avoid that circular dependency, we are using these type def classes. Okay, type def classes are providing what is called the trust they are providing that. Okay, so this class is available in the future. So just now they declared the implementation will be definitely we will do it. Okay, go for that and then we can implement whatever the operations you want to implement, right? So that operations we are implementing in our class, and then no worry, the class implementation will be done in future. Okay, that is the type def classes. Now randomization. What is that randomization? What is the use of randomization? So manually, suppose you are taking some address, property, class, int, address you are taking. That address is the integer data type, means 32 bit. 2 power 32 means 4 GB data, right? So 4 GB data, have you given manually? That means 0, 1, 2, 3, 4, like that. So transaction dot address equal to 10, transaction dot data equal to 50. In this way, I need to provide the value, right? Manually, I can't give. I'm unable to test all the values and I'm unable to give all the values manually. Okay. For that reason, randomization is it plays a key role to execute or to assign multiple values. That means corner cases we need to execute it and then random cases. So randomly we are giving the values. Okay. How many times we are repeating based on the repetition, those many values are getting. Okay. That is what randomization. So randomization means see, suppose he is giving one example. You are buying a car. Okay, so while going for the test drive, they are saying that the instructor is saying, or you are going for a ride. Okay, he is saying that go slowly, 10 kilometers only or 20 kilometers only, and don't go for the second gear, and then don't use the accelerator every time. Okay, just go slowly. In this way, they are giving the instructions, right? but you know car driving, then how you are waiting to travel 10 kilometers per hour only, right? So then you are immediately changing the gear and then giving the accelerator and moving very fast, right? Immediately top gear you are going, right? Within seconds only you are coming to the top gear, okay? So then the speed will be increased. So first gear is 20 kilometers. Then while going to the second gear, the speed will be automatically increased. And then third gear, so still, okay, when you are in top gear, then the accelerate how much you are giving, that much speed it will go there. Okay, so based on that. And also you need to verify like sorry, is that road is right always time? All the time is that road is right? No, right? Sometimes if you want to go for Uti, okay, hill areas are there. Okay, you need to drive there. So we need to get some experience to drive in the hill areas. Otherwise, the car will go back. Okay, so that's what somewhat we are exploring, right? And then during rainy season, have you gone to that same street? No. So because the city nature is there in the roads. Okay. All these are some corner cases. Okay. So not every time we are getting the straight road and not a simple plain road. So but our Indian roads are related to bumpy roads are there and then grass roads are there and then gravel roads are there. All these things are there. Okay. So we need to test each and every time. Okay. That's what the randomization is doing there. Similarly, see what he is saying that I'm taking 10, 20 kilometers hour and then straight roads only. That is not possible. I will test 50 kilometers hour, 100 kilometers per hour and turns, rainy side, rainy time and hill areas also I can explore that. Okay, so that's what he is saying. And similarly, verification also. Instead of manually writing every test values, we are going for the randomization. So randomization will gives you the random values. Okay. Suppose you are giving the range some a equal to dollar random of range 0 comma 255. That means your range is getting 0 to 255. You know that, right? Dollar random. So without using randomization, I can use this dollar random range. I am mentioning that. Okay, 127, 0 to 127. Suppose a equal to 0 dollar random 0 comma 127 means that means a equal to 0, 1, 2, 3, 4 and so on so up to 127 the values we get, right? Same way the randomization also we are using this rand keyword. Okay, during the randomization the keyword is called as rand. Okay, so this rand int address you are considering or rand int data you are considering, okay, or rand bit some at write data you are considering some 7 down to 0 write data. So in this way you are randomizing. The keyword is called as rand. Okay, if you want to randomize, the two keywords are there, rand and randc. What is the difference between them? I will explain in the next slide. Okay, rand and randc. That means randomization in cyclic way, and this is normal randomization. Okay, simple code. Previously, what you are saying that without using this rand class packet uh, bit 7 down to 0 data end class. This is one property you have given. Okay, and then for that property you need to write the module, right? So tb you need to write that. So for that I'm considering module tb and my class name is packet and handle packet pkt. So initial begin object created. Okay, after that then we are not going through these steps. Directly we are assigning. How we are assigning that? Transact packet is that handle, right? Packet dot data equal to some value 20. Similarly, packet dot data equal to 40. Okay, in this way I'm assigning the values, right? So now, whatever the values we are assigning, we are calling the display method. So in this way, I'm calling the display method. But what the extra lines are there in this code? Without using this randomization, this is the basic code explanation we are writing every time. But I want to do manually, so I don't want to do manually. I want to randomize the values. For that, I'm considering the rand keyword, and then I'm not writing the data here directly, and then data is not writing directly. I'm not giving manually. I'm not giving any data. So randomizing that. How we are randomizing that? Your handle is packet. Okay, packet dot randomize. This packet is related to your class, right? Your class, the packet is the class handle. Then whatever the properties methods are there in your class, that will be appear in your tb side. Okay, test bin side. Then I am randomizing my properties in my tb side. So what is the syntax for that? Object dot randomize. Okay, so general syntax is object dot randomize. Okay, in this way I can randomize. What is this object or class handle? Okay, so class handle is that packet dot randomize. Then you can call the display method packet dot data. So now, how many times you are repeating? What is the use of repeat keyword? Fixed number of times you want to repeat some particular statements. That is the purpose we are using the repeat keyword. What is the difference between the replication and repeat? So replication means, so the replication is repeating that. That means variable. Suppose 4 times I want to repeat a. Okay, so this a value you are giving one tick, two tick b 10. That means this 10 10 10 I am repeating 4 times. That is replication. Replication means same value will be repeating fixed number of times. Okay, repeat means some particular statements are repeating. So whatever the repetition you are assigning, those many times it is repeating. Here. So this is the repeat of 5 and then packet dot randomize dollar display ending the code. Then you will get like this data. So 43, 210 and 15, 199, 180. So anyways, different values you will get that. Because my range is 7 down to 0. How many values it will generate? Up to 256. Bit is the 7 down to 0. That means 8 bit. So 8 bit, this data is capable to store 0 to 255 values. Okay, that is the reason we are getting different values. 99, 210, so all these values. This is the randomization. Okay, now we are having two keywords called rand keyword and then rand c keyword. Okay, what is the difference between them? Rand is that randomizing the what are the properties you are considering in your class. So there is no proper order. Okay. Suppose I am considering this is the 4 bit, right? 3 down to 0, 4 bit. Possible values are 0 to 15. Okay. So 0 to 15 values we are getting. 0 to 15 values we are getting. Then I'm randomizing the repetition I'm repeating. Suppose you are repeating 10 times means I have 16 possible values. Okay, 16 possible values. I may get repeated values or I don't get any repeated values. Depends upon the similarity we choose that. Okay, so 0 to 15. So 1, 2, 3. So in this way, randomly I'm getting 2, 1, 4, 5, 9, 11. Okay, 10 times I'm repeating, right? So 10 times 10 different values I may get. I am expecting. But if you are repeating 20 times, 20 times, then you may expect 4 2 times or 9 3 times or 5 1 time, 2 times. Okay. The repetition is depends upon the simulator. Simulator will repeat how many times you are repeating your randomized values. Okay. Based on the range, then values will be repeated. Clear? So 4 bit I am considering. My possible values are 0 to power 4. That means 0 to 15. Then I am repeating 20 times. That means the possible value is 0 to 15 only. But you are repeating 20 times. Then repetition values may be getting. So I am repeating chamber 4 times. Okay. I am repeating U times, U 3 times. I am repeating me 10 times. Okay. Suppose you are taking 2 bit only. So what is the value? Rand bit rand bit 1 down to 0 and then a. So you are randomizing that a dot randomize. Repeating. How many times you are repeating? Repeat 20 times. Begin. That means how many values you will get? 2 power 2. 4 values. It is capable to generate 0 to 3 only. Okay. 0 to 3 values only it is generating. Okay. So then you are repeating 20 times. Then 0 to 3. 5 times may repeat 0. 10 times may repeat 3. 2 times may repeat 1. Depends upon the simulator. Okay. So those many times also we need to pass the test cases. Okay. So suppose one came at 0 simulation time and then same one you got at 20th simulation time. Same condition also you need to pass that. First cycle it is passing and then 20 cycle you got means it is not passing means you are failing. Okay, your test is failing. That is the reason randomly I am giving. See, I am putting it. I want to make you test all you guys regarding system data. Okay, then I am saying that all the topics you need to study. So you studied some all the topics, okay, in history topics, and she studied half of the topics, and he studied 3/4 of the topics, and she studied total topics. Then I am asking randomly questions. Okay, whoever studied all the topics, then whatever the question I am asking, they will answer it, right? Suppose 50% covered syllabus means then we don't expect, right? Within the whatever you studied, so that within the studied limit only you are getting the question or beyond that, right? I don't, I'm not expecting that question. This is the randomization. I'm asking randomly. I'm asking about semaphore, but semaphore you don't know, right? So that's what. So same thing, randomization will be doing that. So random rand keyword is there. This rand keyword is repeating many times. Okay, the number will be repeating many times. Okay. Then rand C, that is cyclic. Cyclic means same thing. I am using that 0 to 15, right? 20 times I am repeating. That means one cycle completion, we are not getting any repeated values like 0, 5, 0, 3, 5, 7, 9, 13, 11, 15. So between that 0 to 15, randomly generating the values but without any repetition. That is the rank cycle. Up to one cycle. One cycle means 0 to 15, there is no repetition. Okay, you are repeating 10 times. Then the range is in within the range only, cyclic range only. Then no repetition will be available. All are unique values. Here, that is the rand and rand C keyword. Rand means within the cycle or not beyond the cycle, it don't care about that. How many times you are repeating based on the range, it may generate different values or it may repeat one only 10 times, two only 3 times. Okay, so this repetition will be happening in the rand keyword. The rand C up to the one cycle completion, there is no repetitions we will expect. Okay, you can't expect any repetition. After the cycle completion, then may expect replicate values. Okay, clear? Rand and rand C. Then constraints. What is the use of constraints? You are repeating randomly, right? Randomization, you are doing that. Then the simulator will generate different values, their own way. Then who is controlling them? No one is controlling, right? So then these constraints will control that randomized values. Okay, so you are there in your class, okay, and then if you not mention the timings, then you will come anywhere, anytime, anywhere. So you will come different ways, right? Then there is no restrictions for you. That is randomization. Okay, but I am restricted. You need to come at 7:30 and leave at 9:30. Okay, so be available in the class 7:30 to 9:30. In this way, I am restricting means this is the constraints. Okay, constraints are used to restrict, control the randomized values. Okay, so control the randomization values. That is the purpose we are using the constraints. So suppose 7-bit value, sorry 8-bit value and considering 0 to 255 values are generated. In that, I want to get even values only. I want to get odd values only. Okay. In that, I want to get even values in odd locations, odd values in even locations. Okay. And I want to get my randomized values in increasing order only. Okay. Some array of numbers I'm considering, all are getting increased order only. And I want to get my array of numbers in decreasing order only. Okay, and then I want to get my values, one value is increased and one value is decreased, one value is increased and one value is decreased. In this way I want to get that. Okay, so in zigzag manner I want to get my values. So all these are controlled by using these constraints. Okay, so you are getting even numbers 2, 4, 6, 8, 10, 12 in this way. Or you will get that odd numbers 1, 3, 5, 7, 9, 11 in this way. Or you are getting the increment values 2, 9, 13, 20, 27. In this way I want to get the increment values. Okay, whatever it may be the values, but increment order only. And then I want to get my values in the decrement order, like 255, 212, or any other values 109 or 111 or 2 in this way. Decrement values only I need to get. All these are controlled by the constraints. Okay, or I want to get only, so you are taking the range values 0 to 255. This is the possible values. I want to get only 0 to 10. Within the range only I need to get the values, because I don't know, so these values are not fitting in my randomization. That is the reason I am constraining that. I am writing the constraint, and then I need to test my test case within the range of 0 to 10 only. Then you are restricting that. You have the feasibility to generate 0 to 255, but you are restricting that 0 to 10 only. How many times you are repeating? So in between the 0 to 10 only, the repetition values will be getting. Okay. Why we are going for the randomization means I want to improve my coverage. Okay. Manually I am writing the different values means my coverage may not be may, my coverage may not be increased, and then my test cases may not be hitting all the cases, like corner cases, stress cases, and pressure cases, back pressure cases. All these cases are not hitting. Okay, so for that purpose, I'm going for the randomization. Okay, this randomization will improve the readability and reusability of your code. Same test bench, different values you are giving. So then reusability will be there, and then coverage improvement will be there. All these things are controlled by this randomization. Okay, clear? So this is the syntax, uh, constraint, constraint name. Okay, flower brackets open, condition you need to write, and then inside that semicolon is there. Okay, within the flower brackets only it is there. Okay, so that is the syntax of your constraint. Constraint name, condition you need to write, and inside the flower brackets you need to end the semicolon. Okay, so this is the basic syntax of the constraint. And then so you are applying multiple variables. So any type of variables I can apply, right? Address, data, write enable, read enable, write data, read data, depth and width, some timing controls, clock, counter, all these things are I'm applying. So while going for the real time projects means so too many signals are there. Okay. So all the signals I want to randomize it. So remember, have you applied the randomization to the output? No, right? You need to randomize the input variables only. You don't have the permission to randomize the output because output you are observing. Inputs are changing. Okay. So you want to test me. Okay. You want to test me. We know the verification or not. He know very well. He came near me and then asking so many questions. Okay, he satisfied with my answers. But still the other person having the doubt. Then that person also came near me and asking too many questions. Okay. So in this way I need to uh, randomize different variables. Okay. So I can apply that multiple variables. Right? So then rand address and data. I want to randomize these values. Okay. So just you can use this rand keyword packet dot randomize. How many times you want to repeat it? This TB never change for all the classes. Same type of TB. And two ways you are writing that. Here, if you write the method means function void and then display, you are writing that, and then dollar display, you are writing address equal to percentile 0d and data equal to percentile 0d address comma data. Okay, so you are printing in your method only address comma data, then brackets close and function you are calling. Then what is your method name? Display. Okay, then packet dot randomize. After this I'm not writing this display. Okay, I can call through packet dot display. Okay, so packet dot display I will get my variables properties. Okay, in this way I can write that. Or normally I can write this in this way, so like class and then random variables and class. Just I am considering the properties, and then I'm calling the properties in my module. So how we are writing the module? Module tb, module name, and then class name. Handle you need to create that. Initial begin. You need to create the object for your handle. Packet equal to new. Okay, or transaction equal to new. And then going for the randomization, how many times you want to repeat it? Repeat 10, begin, packet dot randomize. and then call the display method, or you can assign the you can display the values directly. How you are displaying the dollar display address equal to percentage 0d, data equal to percentage 0d, packet dot address comma packet dot data, because I am calling my properties in my class. Okay, I'm calling my class properties in my test range. Okay, for that, I'm using the handle only. Packet dot display, sorry, packet dot address, packet dot data. Then it is obviously randomizing the values. We are getting the output. Same module, same TB, nothing will be changed. Okay. If you remember this TB, same TB you are using in UVM also. But instead of this new, you are using some create method. That's it. Nothing else different. And relational constraints. Relational constraint means I'm saying that, okay, if I'm there, so you need to be there before that. Okay, if I'm not there, you need to be present after that. Okay, so then I'm taking that address less than data and then address greater than data. That means whatever the data values I'm getting, that value should be less than your address. Address is 10, my data is 20, right? Address is 40, my data is 100. So in this way, I am giving some conditions. So that is relational. Okay, in what are the relational operators are there? Ah, so less than or equal to, greater than or equal to, equal to. Okay, so some other conditions like not equal to, all these things are I'm taking some relations. Okay, so logical relational, and then so equality operators also we can apply that, relational operators also. Okay, that means address equal to data, I'm equating that. Address equal to data. Whenever my address and data are equal, then only you need to randomize that. Okay, clear? So then here I am getting the address less than the data. That means address is 20, data is 50. Address is 11, data is 200. So in this way I will get the values. Okay. So relational operators means whatever the condition you are writing, that condition you need to satisfy, and then you will get the different values. Okay. Clear? And inside keyword. All these are constraints only. Okay. Inside keyword means I told you na, so we have some different range values like 0 to 255. Okay. I will get that 0 to 255. In that, I want to get 100 to 150 values only. Okay. So you want to generate some range values, you use inside keyword. Okay, how you can use that inside keyword? So variable constraint in this way. In this single values also you will get. That means 10 to 20. That means constraint name is the C1. If you want to use C1, you can use, or I want to change my name, range numbers, I am writing that my constraint name is anything, use the defined name. Okay, based on the condition you need to name it. You want to randomize the values within the range. So I want to constraint, I'm writing the constraint to get the range values. Then I'm naming that my constraint is range number. Okay. So inside that 10 to 20, then it is getting every time 10 to 20 values only, and multiple values, and then you want to test 5, 10, 15 only. These values are not hitting in your test cases, then you need to restrict that you will get only 10, 5, 15. Okay, so in this way you are restricting that. Clear? So otherwise, I'm writing some mixed set of ranges like I'm writing like this 5, 10, after that 1 to 21 to 100, and then 151. So in this way I'm giving the mixed number of values. That means individual values I'm giving and range values also I'm giving. Okay. So that is the inside keyword we are using. See, he is constraining that multiple values, one address is there. Inside that 0 to 15 values he want to generate, and then 100 to 120. That means you will get the values 0 to 15, after that 100 to 120. So here 8, 14, all these things, and then 110 or 102 or 119, these values only you will get. Here. So that's what inside keyword. Remember all these things. And inverted inside means beyond the range. If you are mentioning some range, see previously I mentioned that 0 to 15 and then 100 to 120. Except these values, I can get remaining values. If you are using inverted inside keyword, just apply the not inside in front of the condition. Okay, so just apply the not condition here. I'm taking the address inside that 10 to 20. Okay, this 10 to 20, I'm not, I don't want this 10 to 20 values. Beyond this value, I want to get, that means 0 to 9 and then 21 to 255. These values I want to get. Then I'm considering that not inside address, not inside. Okay, not keyword you are taking means that is not generating within the range, whatever the range you mentioned. Hmm. And then you know that constraint blocks. Some blocks I am writing. So within the range you want to get that. Then address should be less than 100, and then address data should be greater than 50. Okay, your address within the range 100 only you need to get, and then data may be get 50 greater than. That means address equal to 10 you are taking that, and then data 51 because beyond the 51 I need to get. Okay, greater than 50. Okay, so that means up to infinity you will get, but depends upon the range you are mentioning, some big byte or integer, whatever the range you are considering. Based on that you may get values, right? Clear? So that is the conditional constraints. And conditional constraints I'm depending upon the some condition. If a greater than, or if I percentile by 2 equal to 0, that means my index values are all even, then only I will get that values. Okay, so in this way I am writing some conditional. So this if mode is 1 only, then only I will get this address inside that 100 to 200. That means you have enable pin, right? Enable is 1 only, you will get this address values. Or enable 0 means you may get the address 0 to 50. Yeah. So that means you are giving the restrictions to get the values of your address depends upon the mode. If mode is 1, I may get the values inside between 200 to 250. Okay, so 250 values I may get. If mode equal to 0, my address should be getting 0 to 100 in this way, or 50 to 100 I am restricting that. Okay, these many values I want to consider. Okay, so for that I am writing the constraint. Okay, so conditional constraint. And then implication operator, it is also like a if else condition. Okay, so you are writing the if condition and else condition, right? If condition is true, then only you are getting the value. Okay, so that is the if. Okay, same way implication operator. So implication operator, how we are using this one, hyphen greater than symbol. Okay, This is the hyphen greater than symbol. That means previously I told you mode equal to 1, my address should be 100 to 200. Same way. Mode equal to 1, then your address should be greater than 100. If mode is 0, then your address may be not greater than 100. In between the 100 only you will get there. Here. And then soft constraint. What is the use of soft constraint? So you are using some inline constraint. That means you have you forgot to apply some constraint in your class. Okay. And you are writing some constraints in your module also. That means EB also you are writing some constraints. At that time, I don't know what type of constraints you are writing in your class. Suppose address greater than 50 you have written. Okay. And then you have written another condition is address greater than 100. Then you may get values, right? Because address greater than 50 means the range is already beyond that. And then you are taking that address greater than 20 means then again the values will get because the range values in between these values also added. But you are writing some constraint upside address greater than 50 and you are writing another constraint address less than 50. Which constraint I need to consider? Less than or greater than? I didn't get that, right? So simulator may be confused because sometimes you said that greater than value, sometimes I said that less than value. Then which value I need to consider? Okay, so that is the reason the simulator will get confused. Whatever the constraint you don't want, beside that you need to write the soft key. Okay, multiple constraints you are writing, some conflict may get, so that conflict I need to avoid that. Okay, so then I can mute some other person. Okay, so then the keyword is soft keyword I will use that. Okay, so that's what soft keyword when used default values is needed. So then address is equal to 100. Okay, so that can be overridden later. So address equal to 100 is overridden later. That is the reason soft keyword is used. That 100 I don't want to get. Remaining values I will get. Okay. Solve before prioritizing. Okay. First solve the address, then only assign the data. Or first solve the read operation, then only go for that other increment condition, decrement condition, all these things. First read the data. Study and then implement different conditions. Okay, solve before. So solve before is giving that priority. That means solve more before address. Before address assignment, I need to assign the mode value. Mode value is 0 or mode value 1. Okay. So and then dynamic constraints. Sometimes I don't want to constrain that. I want to disable my constraints. Okay. So disable constraints, how you can disable that? Packet dot c1 dot c1 is the constraint name and constraint mode of 0. Okay, if you are assigning the 0 means disabling. If you are assigning the 1 means enable. Enable the constraint. Okay. And inline constraint. Inline constraint means you are writing object dot randomize with keyword you need to use that. Okay, what is the syntax for that? Object dot randomize. Okay, with keyword. Where you have seen the with keyword? Array finding methods. Okay, array locating methods. I want to get my array values less than 20. I less than 20. Item less than or equal to 20. Item percentile by 2 equal to 0. Item greater than 50. So in this way I have utilized. So If you want to find some values within the range or out of the range, then you go for that inline constraints. Then object dot randomize with keyword you can write that. Okay. And also pre-randomize and post-randomize. So what is the use of pre-randomize, post-randomize, and then randomize? You are putting a cake. You are baking a cake. Okay. Before that, all ingredients you need to get there. That is pre-randomize. And then you need oven to cook that. Okay. So that is randomize. After that, you are decorating that. Okay. That is post-randomize. Okay. So before randomize, I want to get the values. During randomization, and then after randomize also, I want to get the values. Okay. That's what. Just take a break. Okay. So see the summary. See this code. Just I am executing the randomization code. Class packet, and then rand bit 7 down to 0 data, and then rand bit 3 down to 0 id, rand bit valid. Method I have considered. Method function void display inside packet. Packet equal to data, and then id valid. Okay. So data id valid I am displaying in my method. Okay. So then module, uh, my top name test rand, and then packet class handle. Here null object is there, and then initial begin packet pkt equal to new. That means object is created. Generate random values. Repeat 250 times. Okay. Set packet dot randomize. That means here every time the random values are checking. Okay. Packet dot display. Okay. So then this asset is the assertion. It is checking throughout the simulation. Okay. Throughout the simulation, it is checking that. So you are you getting the randomized value or not? Okay. Then I'm executing this code. See, so 250 times you are repeating that. Okay, different values you may get. Okay, 7C 6459, 7B 4550, 82, 87, different values I am getting. And then IDs also we are getting different values. And valid should be 0 or 1. One time 0, one time 1. So this the valid value is repeating. Okay. So then see here why this valid value will be 0 here. Just I am not giving any condition, right? That is sometimes valid value should be 1, sometimes valid value should be 0. Suppose you are giving some condition. Within the condition, then valid value should be 1. And you are getting the beyond the values, then your value should be 0. In that case, I am checking the value condition. Okay. So sometimes I'm writing the data. You are giving the acknowledgement. At that time, I'm not getting the acknowledgement. That means my value should be 0. Okay. So that's what. Clear. And then complete advanced example. In this I'm checking address data burst. See, inside keyword is considered constraint, constraint name, address constraint, address inside that 1000 to 1 FFF, and then your burst type is inside 1248. Like burst types are there in the XA protocol, burst types are there, right? So type 1248, in this way the burst type I have mentioned that. And then relation constraint, so data is greater than address. Always I need to get the address data greater than my address. Method you are displaying that. What you are displaying? Address data burst, and then address data burst I am displaying that. Okay. Module TB, class name, and initial begin. Okay, transaction equal to new. Repeat 10 times. Transaction dot randomize. Okay. So sometimes you may take a set, or you are not taking the set. There is no problem. If you are taking the asset, just checking throughout simulation. Okay. So if you want to repeat this one, I'm not calling the display, right? So how we are getting the display here? So begin, you are using the begin, and then I'm calling this one asset packet dot randomize. Okay, and then what is the display method here? Transaction dot display, right? So, okay. So I'm using the post randomize. Okay. Then there is no need to write the display after randomization. It will automatically display the values. Okay. So that is the reason I'm not writing the display here. No need to end, right? Begin. Just repeat the session. See. So that's what. After randomize, we are getting the values. How many times you are setting that? So those many times it is repeating the values. Address is always less than compared to your data, because data greater than address and considered less. Okay. If else constraints. In this also I am writing some different conditions. Whenever I want to check the different conditions, then go for the if else conditions. Okay. So if else constraint like alternate path. If condition is true, check the true condition, or otherwise alternate condition and checking there. Okay. Without constraincy, randomization is like a GPS driver. Okay. Without constraints, GPS go anywhere, right? With the constraints, within the range only we are checking that. So that is that without constraint, drive anywhere. And with constraints, you are checking that during training, go slow. And bumpy road, you need to go slow. And then hill areas, you need to give the accelerator more. All these things we are saying. Okay, that's what constraints we are taking. Then in this way, if condition, if sunny, drive normally. If showing, sorry, if snowing, drive carefully. So in this way, the conditions we are saying that if else condition. If we are giving some condition, if it is there, then write the constraint value. Give the constraint value. If it is false, give the another constraint value. Okay, alternate path we are taking them. See, why do we need if else constraint? Suppose we are verifying the XA protocol, in that burst is fixed. So length is less than 4, and then increment burst I am taking that. Then length is less than 16, and then wrapping burst I am taking that. Then length should be 2, 4, 8, 16. In this way, I am giving the conditions. Okay, if the burst is fixed, what is the address length value? Less than 4. In this way, I am giving the condition. See, if my burst type is fixed, if it is equal, my length should be less than 4. And then else condition. Burst type is increment, my length is 16. And then length should be else condition, length should be 2, 4, 8, 16. Because nested if conditions I am considering three conditions, 1, 2 if else conditions are considered. Okay, other condition else condition. Okay, so basic syntax for the if condition, constraint name, inside that if you can consider, and then condition after that expression. Okay, so condition expression, if else condition also same thing. Okay, so constraint name, and then if condition expression 1 and else condition expression 2. Okay, alternate part. If else if, okay, that means nested if conditions. If condition expression and then else if condition expression else expression. Okay, so this is the basic if constraint. If you are, I told you right, enable should be 1. My data must be greater than 100. So then only I am getting the if condition. So if I am checking that my enable should be 1, then my data will be greater than 100 will get. See, I am not written any method here. That is the reason I am writing the display method in my TB only. Okay, packet.enable, packet.data. Same thing, module is common. Class name, handle, initial begin, and then object creation, repeat, randomize, display. That's it. If else constraints. That means previously I am considered if only. Okay, so same thing, my scale should be low. Okay, I am considered type that enum. Okay, in that low, medium, high, and consider. Okay, if my scale should be low, then I will get that value less than 50. If it is not low, I will get the value greater than 50. Okay, just giving the conditions, simple conditions. Okay, same way else and if else if. Okay, three conditions. Previously, I have considered two because if another condition else, low, mid, and high also I have considered here. Okay, so now if your scale is low, less than 30, medium, less than range inside the range 30 to 70. If it is low is completed, mid is completed, then rest is high. So else condition high means you will get the value is greater than 70. Same thing, burst types, same low, medium, high, then fixed, increment, and then tracking. Three burst time considering. Okay, so same condition. If your burst time is fixed, you will get the address length less than 4 and then greater than 4 in this range. Okay, inside the range I am mentioning that. And then nested if conditions. Nested if conditions means multiple if conditions. If master is begin that, then you will get that address is greater than 100 or else condition less than 100. Same way conditional operator. How the conditional operator is working? Condition is true, true condition will be getting or false condition will get. Okay. So similarly, protocol verification, what you are verifying that read write address data. So constraint you are giving, if read write bit is 1, data is not equal to 0. That means your data may be any value. Okay, you are randomizing that. And memory verification that aligned address. Your address should be divisible by 4 means you will get that aligned address. Okay, same thing. I'm writing this memory verification. My address should be aligned. That should be multiples of 4. Okay, so that is the reason address percentile by 4 equal to 0. Okay, that means I'm getting the address is aligned address. Some CP verification of codes, all these things. Just see this all the codes. Okay, just read this one. if else conditions. You are writing anything, right? What when to use if else constraints. One randomized variable is there, so we need to control one variable, then conditional checking. Then we are using to verify AHV, AXI, APB, Ethernet, all these things, equal conditions and taking them. Just we'll go for execute one code related to if else. See, basic if constraints. When enable equal to 1, data must be greater than 100. Okay, it is saying that condition. So enable should be 1. My data should be greater than 100. Okay, so just check this condition. If class packet enable and data constraint name if enable and data greater than 100. Okay, so and then I'm commenting this one also. Then module DB packet handle creation and then packet dot randomize writing the display method. Save and see, whenever enable 0 you are getting less than 100. Okay, whenever enable is 1 you are getting the data is greater than 100. Okay, huh. Sometimes maybe failure. Okay, so we don't expect that, so that time we may get different values. So like set we can use set packet dot randomize still same value. Okay, suppose I'm using this uh, rand c instead of rand keyword, rand c I'm using. Okay, so what is the data we will get? How many times you are repeating? 10 times. Then you are getting different values 10 times. Huh. So up to this, okay. So then here, sometimes it is failing. That means I don't know. So that's what I am checking. So why it is failing sometimes. Okay. All the times I need to get different value. Because if you consider the else condition, then you may get different values. Okay, so without considering the else, what happens here? Data less than 100. Now the range you mentioned, right? So that is the reason maybe the else condition you are not mentioned. That is the reason it may take different values. Okay. So now enable is 0 less than 100. Enable is 0 less than 100. Enable is 0 less than 100. So enable is 1 I am considering. Then greater than 100 I got that. Okay. So rand C I placed, there is no repeated values we will get. Okay. Here, that is the reason else condition also we need to check that, because sometimes if you are not giving the else condition means so similarly we may take different values. Okay. At the time also randomization failures. Same way implication operator. Shall we continue?